Hello, everybody. Thank you for joining our session. Super happy to see you here. We have a very interesting session today about recommendation engines. First of all, I just want to explain how the session is going to work. So we will have the presentation for about 15 to 20 minutes, and then we will open for questions. The questions are only via the chat, and you can ask your questions whenever you want. In the end, we will ask them to our speaker. Also, if you want to interact with other participants of the event, you can tweet, and then don't forget to use the hashtag datalift for this event. And so my name is Aline. I'm a data scientist at Flaconi, and I will be the moderator of this session. And our speaker is Dr. Yernat Assylbekov. So Yernat has a PhD in mathematics from the University of Washington, and then research experience in different institutions. But at the moment, he's currently working as a data scientist at Delivery Hero. And he is going to tell us about his experience with recommendation engines there. So we can get started. Don't forget to write your questions in the chat for us. Thank you. Hello, Yernat.
Hello, Aline. Thanks for introduction, and thanks for inviting to such a great event. I hope we would have like this kind of events as much as possible. It's a great pleasure to be here. So yeah, as you said, I'm going to talk about recommendation engines in particular for food market, food ordering in restaurants and grocery stores. So our company, Delivery Hero, was founded in 2011 by Nicholas Osberg. We are operating in 50 countries, maybe already more than that. We have more than 30 brands. And our company is a pioneer in Q-commerce. So that's like a next step in e-commerce, where we have like stores which will deliver. So these stores doesn't exist as a regular stores physically. You cannot go there in person, but you can order groceries from there, and they'll be delivered like in 10 to 15 minutes. So we are working in over 700 cities around the world, and we have 600Ks over than that restaurants. And per day, we get approximately 5 million orders, sometimes more, sometimes less, so it depends. And we are proud that our Berlin headquarters office is very diverse. We are very proud of diversity. And currently, we have over 100 nationalities working there. So that's like overview about the company. And this is what you can see here is the list of our brands. As I mentioned, we have like a 30, so it's not all of them. So like, for instance, this Talabat you can see here, and Carriers, these are for Middle East and Northern Africa countries. We have this Food Panda, which is mainly for Asian countries. Foodora for European, and I don't know, Yemek Sepeti, this is for Turkey. So here operating in a lot of places. So we have a lot of data. So why recommendations? Why this is important? And I think the best answer for that question is actually quote by Steve Jobs in 2009, which says, a lot of times people don't know what they want until you show it to them. And in many cases, this is true. In other words, recommendation engines help users to discover something, some relevant items or some relevant content or people, depending on the use cases, which can be very relevant, very interesting, but they never thought of. And that usually happens for me personally when I want to watch some new movies in Netflix or something like that. And this is actually the alternative to search engines, because these recommendation systems sometimes are much more convenient. If the recommendation is relevant, then it is really convenient to use those. And in the business nowadays, it's one of the most powerful machine learning algorithms used in industry. So here I list some list of recommendation use cases. As I said before, like Netflix, they use recommendation engines to show interesting content, which will, as a result, increase the watch time and get the attention of the user. We all use LinkedIn to find relevant jobs, and actually, also we use Facebook to find relevant people. So this is they somehow also work on the similar projects. So like if in LinkedIn they show job listings to increase the applicants to the corporations, and both LinkedIn and Facebook show relevant people to build better connections. Amazon, we know all Amazon, they use recommendation system to recommend relevant products that will increase their sales. So that's very important for the business. And in Delivery Hero, we recommend interesting dishes, interesting right here vendors, but this is like restaurants, or it can be stores. And that will, for the company, give conversion for more orders. So recommendation, there are a lot of types of recommendation, but personally, in my experience, I divide these recommendations to two types. And one is like a content-based filtering, another is collaborative filtering. And of course, we can. I'll talk about these two types of recommender systems in more details. But I want to point out here that this content-based filtering is mainly not user-specific. It can be user-specific, but usually it only considers on the content of the items that you have. For instance, if you have items in the cart and you want to recommend some other items, in content-based filtering, its main goal is to recommend based on the items that we have in the cart. But collaborative filtering works on its focus is mainly user experience. So it's going to be specific to that customer. So it will take also care of the contents, but main target here is personalization. And of course, you can do like a hybrid. You can mix them, but that's even harder task. So what we are using to recommend dishes or restaurants, we use embeddings. For instance, if it is we are working with product names or restaurant names, we use embeddings from most basic TF, IDF to more complex like Word2Vec or Doc2Vec, something like that. And since we are recommending some items, we need to have some sort of similarities, a measure of similarity. So we will work with different types of similarities, cosine, k nearest neighbor, or sometimes characteristics matching. For instance, if your product has certain characteristics like a spiciness level or type of cuisine, we use all of this. Or it can be allergies or like a type of a meat, lots of things, lots of characteristics you can use. And to make an inference, that is to make actually how you build your model to recommend, you can use a lot of different approaches, from Bayesian to matrix factorization. You can use neural networks. And then even sometimes some heuristic approach, which I call here simple math stats, mathematical and statistic formulas, even those are really good. I know like some people underestimate this approach, but actually they perform really good. So everything depends on the case, on the algorithm that you want to develop. And about the characteristics that I was telling, it depends on it can be a vendor level characteristic, like what kind of cuisine is served there, and the product level. It can be time of the day, like if it's a breakfast time, it's not good to recommend, I don't know, like a foods that people usually eat during dinner. Coffee might be a better solution for that, yeah. And we use feedbacks from the user, like it can be explicit feedback. Usually these are ratings where they give ratings from 1 to 5 star, or like dislike after they purchased the product, or even like their experience with delivery. And also we use feedback which is implicit. I mean, in most cases customers don't leave feedback, I mean explicit feedback. So in that case, we look at the orders as it can be like if the customer did place an order, it is definitely like a positive signal. But it can happen that after that order, customers didn't order from that restaurant or that particular dish. You can consider it as a negative signal. Reviews, some customers leave reviews, so we use those as well using NLP, and yeah, bookmarks, and we can track clicks, interactions, like did customer add to cart, and was the customer looking for some particular type of the food. Yeah, you can use lots of variations of feedback which is implicit. Yeah. So let me quickly discuss about what is the content-based filtering. So it's like a general overview. Of course, I'm not going too much in details. So in the content-based filtering, what happens, like for instance, the customer is ordering some food, maybe currently, maybe in the past, it depends on the case. And then we take the characteristics of this food, of this dish, all the characteristics of the restaurant where the customer is making the order. And we have some algorithm, content-based filtering model that I call here. It's very vague, but it will depend on the case. And this algorithm will give us some dish which is similar to the ones that customer bought, and we can recommend it to customer next time. Or it can happen that customer is about to make an order. He ordered, like, I don't know, this kind of burger, but we can recommend him a Coke or some other drink. And this can be personalized and also non-personalized. So it depends. Of course, non-personalized way of recommending is way easier, but personalization gives additional challenge, like a taste of the customer, his preference, and so on. So that's like a very big, like a rough picture of content-based filtering. So again, in here, the algorithm is mainly focused on the content to which we do recommend, not on the personalization on the user experience level. But the collaborative filtering is somehow opposite. Here we focus on the user specific. So, for instance, again, like this user orders these two dishes, and we find similar users who have similar preference. It can be, for instance, that a user did order similar dishes. And we also look what this similar user ordered in the past. So with this product, this user might also order Coke. And based on that, we have some model, and that will output us this product, and we'll recommend it to the customer. So again, like this will look at the similarity not between the products, but between the customers and what other similar customers did order. So that's like a general idea of collaborative filtering. So examples, for instance, if you look at this case, we have this Kellogg's cornflakes. The customer is looking at this product, and it might happen that this product doesn't exist right now in the store, and or it doesn't need to be so. Like in any ways, we could. What we can do, like a content-based filtering, would recommend similar products. Actually, no, this one, best match for this product. So products that might look similar to this. Of course, it will have some mistakes, for instance, like this carrots that is not that similar to this, but it depends on the algorithm. It could happen that this carrot was frequently bought with this product. That is why it is recommending. But if you look at this one, this is also this kind of cup noodles. Yeah. So this algorithm is saying that, well, these products are best match for this, depending on the algorithm. But this part is like more personalized. It's called similar products for you. So it is trying to find the similar products, but more like a personalized, specific to a customer. And this is example of we recommend different types of dishes based on the customer's history. It seems that the customer likes some Asian food, and we are, like you can see, this algorithm is recommending dim sum and other types of Asian type of food. I don't know, but all this looks very, very good. Yeah. So these are two examples. So important steps in that I want to discuss about when you build your model to production is choosing the right features is very important. As I said, this can be like depending on the algorithm, depending on the purpose, it can be different type of cuisine type, spiciness level, and the others, day of the time of the day of the week, actually sometimes even affect. And choosing the right objective. Another important step is like, do you consider orders as a positive sign for the algorithm, or do you consider even like when customer added item to cart? Customer didn't purchase, but he added item to cart. You can consider that one as a positive too. So it will depend on the problem. So you need to choose the right objective. And also evaluation metrics, that's another very important thing. Like lots of these evaluation metrics, like I don't know, like accuracy wouldn't make sense in the in this kind of business, in the recommendation systems. So depending on the business, depending on the purpose, you need to choose right evaluation metric. One can be like you want to increase the average order value, so the average value as like a monetary value you get per order. That's another one. Or you can increase the gross of that. So, and designing the model, designing model is you pick the right model, you train it, you evaluate it, which brings us to next bullet point, which is offline evaluation. So this is essentially what is, if you like take online courses, they teach it like it's like a testing set. So you need to, after train, we have this sound validation set we are using within the training. And then after all this training, hyperparameter tuning is complete, we do offline evaluation. So this is one step before we push it to production. And when I say push to production, I mean like we push it to A/B testing. So of course, at the last step, we do A/B testing and check if our algorithm is really improving the business metrics or not. And And so we have a lot of strategies, and one way to combine a lot of strategies, you can see here the picture. If you go to the website of websites of our brands, you can see like this kind of horizontally scrolling widgets here, and each such widget is one recommendation strategy. For instance, like these are top rated. This is order again, which is pretty simple algorithm. It looks at the past orders of the customer and recommends them ranking by which orders were, which items were ordered more frequently. Some others like recommended for you, as I said, like this is more, again, more customer specific, but top rated is not customer specific. It is among all customers. So it's more content based. So this is the way how we combine different multiple strategies, and we do measure conversion rates for each of these strategies separately. And also we have some other projects going on in the data science side, which is, for instance, related particular to this case. We made an analysis, and that analysis showed us actually the way we put these strategies, the order we put, make really a lot of, it is kind of important. And so we are currently using reinforcement learning to find the best way of ranking. And also another project that we are working on right now is a cross-sell, which is you recommend additional items to a customer when the customer is about to check out. So it will increase the sales. This vendor's recommendation is something that we did work earlier, but we continue working on it, improving, and also similar products recommendation. So in recommendation system, we never stop. I mean, we get some achievement, and then we try to improve it further. Yeah, to the next step. And finally, I want to run quickly over our architecture and technology stack. So all our strategies, most of them are built mainly on Python and its different libraries for machine learning, like a TensorFlow, Pandas, PyTorch, whatever, scikit-learn. And we store them in the GitHub. We also provide Docker containers. And those are we push them to the container registry using Jenkins. And we have here Airflow scheduler, which will schedule our apps, wrap it in Kubernetes pod, and then for the Airflow part, we have this DAG generator, like automatic DAG generator. We use DAG config files, which will tell us which algorithm to use in which cases, for instance, in A/B test or whatever. And those are automatically generated. I mean, those are used to automatically generate these DAGs. And then we, as I said, we wrap our algorithms to Kubernetes pods, and then we recommend, and we like our recommendations are stored in Google BigQuery or cloud storage. It depends on the algorithm. Sometimes we have online algorithm which do online computation. Some algorithms do like a pre-computation, and we ingest the data to Postgres. So you can see here, if it is pre-computed, we get it from the Postgres. And if it is online, we get it from the Google storage. And we have different APIs for our different algorithms. And usually we implement our APIs in Fast API in Python. We monitor our APIs using Datadog and Slack for having some alerts. And we have a API gateway, which is, in some sense, it is sending, so it is getting requests from the customer, and depending on what strategy we need to use, it will send a request to the corresponding API. So this is like in general how our architecture. I mean, how our recommendations work. So last thing that I want to say is currently we are looking for data scientists, for data engineers, and actually for Python engineers. We have lots of open positions in different departments, and our headquarters is in Berlin. So reach me out in LinkedIn if you have questions. Yeah.
Thank you so much, Yernat. The presentation was really great. I'm sure all the participants heard very interesting things. We do have a few minutes left. And we already have a few questions in the chat. If you have more questions, post them quickly there. I will start with the first one. The question is from Anya, and she's asking, at what intervals do you rework the recommender systems? Or is it event-driven or feedback-driven?
So it depends, but usually we retrain our recommendations engines daily.
Okay, cool. The next,
if that's enough for as an answer.
Let's see. I can move into the next one, and then we can get some feedback from Anya in the chat. But Alex is working. So what strategies have the best conversion rates? For example, for food, movies, or products? And what does conversion rate actually means here?
So we have about the conversion rates. Let me start with that one. We have different conversion rates. One conversion rate is did the customer click on our one of our recommendations. So this is what we call micro conversion. This is like a first step to get attention of a customer. And the next conversion is if the customer did actually order from that strategy actually. So after clicking the first time, did customer order from using our that recommendation engine? So this is another conversion.
Okay, cool. Thank you. Thank you for the questions. Yeah. Do you want to say something else?
Yeah, I didn't answer for the first part of the question. So it like the business of food ordering business, food delivery business is very specific. Like if you look the difference between movies, recommending movies, is usually people tend to order more what they have ordered earlier in the foods. Like for instance, if you like burgers, you keep ordering burgers. You can interchange with something else, but people usually like ordering the same thing. In movies, it's very rare. Like you watch one movie, it's unlikely that you will watch that movie again within like a month, right? So you want to watch something new. So this kind of things you need to take care when you build your recommendation systems. But I cannot tell which recommendation system performs the best, because they are all kind of very different. One is recommending the things that you did order. Ones are like recommending when you just come as a customer. We don't know any knowledge about your preference. Yeah. So it depends.
Okay, interesting. I think we have time for just one very quick last question. Thank you so much, you all, for the questions. This one is from Jakub. It's, did you update your models or build new ones because of COVID-19? How successful were old models in Corona times?
Wow, that's an interesting question, because I actually joined company during the Corona time, and we keep improving our algorithms. Since the demand did grow, it's very interesting questions, which I think even all recommendation systems were doing pretty well, but of course, as a business, we want to improve our recommendation even if they are doing well. So as like one of the kind of how to say, one of the things that we do really care at delivery here, we aim higher always. We want to, even after improving something, we want to improve it further. Okay.
Cool. Yeah.
So
very interesting times. Yeah, for all data scientists, I think. We have to, unfortunately, we have to end our session. But thank you so much, Yernat, for this session and for your insights. And thank you for all the presenters and for the great questions. And then maybe if I couldn't ask your question now, you can approach Yernat later and yeah, have a chat with him. Thank you so much.
Yeah.
And I hope to see you again in another event. Have a great day. Bye-bye.
Bye.